Right, we'll make a start. Thank you all for coming. Thanks for coming to this TechEd presentation of the Interaction Continuum. My name's Mark Manderson. I'll lose the nerves a little bit by telling you a little bit about myself. I'm the head of development at fingertaps.com, a company who makes gesture-based games and applications for OEM markets around the world. We've got applications on millions of machines around the world in different countries and in different languages. We worked on very early touch-enabled systems, and we now sell to places, companies like Intel, Acer, Asus, Sony, and through manufacturers like Intel and AMD. I moved from the early days. I moved into development, and then through development to software architecture, then to project management, and into what I am now as head of the development for the team. As our company grew from about 5-man team through to what it is now at about 25 members. I've been in the industry for about 12 years, but I've been interested in these sorts of things for many, many more years than that, since way back when the Commodore PET was in our high school computer club area. So I've been doing it for a little while, programming, and then on to the more strategic stuff now. Anyway, that'll do about me. We'll get on to this interaction continuum. What I want you to leave here with is, firstly, why you should care about it, and what the hell it is, and what are some of the limitations that you'll encounter when you use this system. Technical difficulties, no. And how you can use the principles in your own applications, because you don't have to use the whole thing. You can use parts of it. You can maybe only use one little point, which is something that we've used in the past in our touch systems. We've just used one part of the whole continuum. What is it? It's effectively the melding of interactions or of user interactions through a wide variance of distance. Starting off at the computer, we've traditionally used keyboard and mouse. We're all very familiar with that. Going to touch screen. Moving back out of that, we've now got ways of interacting with the machine from distance, and basically it's moving through from that distance, from that quite long distance to into the computer. Now, as you move away from the computer, you can't do quite as much with it. Of course, the start off, you can use the keyboard and mouse to do quite content-driven things, creation-driven things, productivity-driven things we do every day at work. Once you move away from the computer, you're really in a consumption space and an entertainment space. Although that can change. And at the moment, we're in a consumption space, we're in an entertainment space. You've seen out in the hub people running around and being silly on the Xbox with Kinect, those sorts of things. The average user doesn't care about the technology that we are using to bring them together with their computer. They really don't care that it's a depth camera or whatever it happens to be that we use. They just want to interact with their computer in the most natural way possible. There's a lot of paradigms to creation and consumption paradigms to deal with and consider as the technology allows the user to escape the keyboard and move away. And we're just at the very, very start of that journey. What are we going to need for this journey? We're going to need some input mechanisms, some good ways of being able to move that person away from the computer. to get them out from behind the keyboard, out from behind the desk, and using it in a rational and reasonable way. We need a good software layer, something that we can use to do that with, and engaging content. And this brings to mind back in about 2005, we created a product that was a kids productivity tool. It allowed the children to create stories and engage their parents or whoever else in these things. And we created a small little thing. They could take a picture on a blue screen and put themselves into the story. That allowed them to make a story about themselves, not just about some arbitrary random character on the screen. And they could actually show themselves cooking, or show themselves playing with the dinosaur, or whatever they wanted to do. They can engage their imagination without the worry of having to deal with how they were going to do it. And that helps. That's what the user wants to do. They don't want to have to worry about how do I get this into the computer. They want to worry about what the story that they want to output to their friends, their colleagues, their family, their invisible friend, whoever it happens to be. So it needs to be engaging and novel. And of course, the other end, we need a way to feed back that information to the user, so they understand that they're doing whatever they're trying to do correctly and right. So if we start with the input mechanisms, because as far as interacting with the computer away from the keyboard, that's the most important part. Well, it's one of the most important parts, one of the thing that's going to start up anyway. So we've got things like voice recognition, depth cameras, sensors, touch screens, and direct input mechanisms. They're just a few of the well-known ones. There are others, and laptops and computers in general are now just starting to come out with some of these things on them. I mean, they've had webcams for a long time. They've had reasonable mics, and the mics have got better as they go forward. Some are coming out with touch screens now. Of course, things are going a lot better in that space as well. So we start with voice recognition. Fun factors high. Wouldn't everyone like to be able to ask their computer to make a cup of coffee for them, or do the whole Star Trek thing? That'd be lovely. We're not quite there yet. But the control area is large. You can be away from the computer with a few limitations that I'll go into in a few minutes. Very little user training is required. We all know how to speak. I'm doing it right now. We learn from a very young age. We learn when we don't know we're learning. We've learned to ask for a bottle when we were just walking. We still ask for one now these days occasionally too, in a different way. So there's very little user training required for the user, the person who's actually going to be doing this, and it's a natural mechanism for communication. Of course, there are a couple of limitations. At the moment, the machine generally needs training on your voice. You need to train it up to understand you. There are so many different inflections and different ways people talk that even now it can do a reasonable job. Siri and Google Voice and stuff like that can do a reasonable job of picking up commands. But if you're trying to talk to it in a natural human way, you're going to find it needs some training and some knowledge about your specific speech patterns, because they're hard for a computer to parse. We do it all the time. We've got a reasonably large computer in our heads that does it for us. We've been doing it all of our lives. The computer hasn't. It doesn't know how to do these things, and we can only do so much from the software side before it starts having to do stuff with you. Noise cancellation. There's a lot of ambient noise in the world. very rarely are you in a situation where, or is the user in a situation where they can shut off all the noise. There's TVs going in the background at in a family situation. There's the kids running around screaming at their friends. Or at each other, much more likely. And in a workplace, there's other people chatting behind the scenes. There's other things going on. Everyone's busy. Everyone's doing stuff. So the machine has to be able to remove that noise, and it's noise because sometimes that noise might be required as well, because, of course, it may not be just that one user who wants to talk to the machine. It may be several in the room. So that brings into play big data, large machine loads, and currently it takes quite a hefty machine to be able to do all this stuff. And of course, the last one, and not by any means the least, is user frustration. The problem is that we have to currently talk to a computer in the way that a computer understands, not the way that we understand. So we have to talk to it in stilted conversation, give it time to understand what we're doing or what we want it to do, tell it off because it's done it wrong, and then try and get it again. And for us as people who are into technology, I guess we take that and we do it. And the frustration's a little less because we know what's going on behind the scenes. But your average user, mum and dad, etc., they will throw the computer out after a few minutes because they're just so frustrated that it can't understand what they're trying to teach it to do. So after voice, which is sort of all-consuming because you can do that right up at the computer, you can do it away from the computer and anywhere you like, we go to the depth cameras, the things like the Kinect and other ones that are coming out. It allows you to track a hand, a skeleton, a face, to recognize people to some degree, as long as they're looking at it, to pose, to gesture, and it's interaction over a medium distance. It's interaction with the user in somewhat of a contrived way. And is anyone out in the hub playing with one of the dance centrals or whatever out there can tell, it's fun to do, but most of the things, most of the applications that it's being used with at the moment are more based around physical activity, dancing, training, physical training, and the likes of that sort of stuff, the adventure games and things like that. It can track you in respect to other objects relative to it, and there are ways that we could use this thing to track that person in a room and do good things for them in the future. So what I thought I'd do now is I'm just going to show you a bit of a demo application of primarily head tracking and a video of head tracking, and it's a prototypical demo that we did a little while back. It shows movement through different distances from the machine, and will give you some sense of in a very rudimentary way what can be done with it. I'll just set this thing up and get it going. Try and see if we can get this through. And that's the wrong one. Awesome. If I can find this cursor again. Where's it gone? Sorry, it's just queued the wrong one first. Is there a playlist? No. Sorry about this. Always get at these issues when you... Right. That should be the right one. Okay, so this shows one of my colleagues playing around and moving. It shows that as you move closer to the machine, it's giving you more information. He can use gestures to move around. This is a contrived prototypical application. He can move up and down and around as he goes forward, showing different levels of interaction for the user as we go on. He moves out again. He can then pan around and do other bits and pieces with it. Shows. Sorry, getting over to it again. It's all done with skeletal and head tracking, using a Connect and the Connect SDK, which I'll show a little bit more of in the future. It just gives an idea of the fact that when you're far away, you can only show a limited amount of information. I mean, that's a huge screen, but generally you're on a 24-inch screen, or if you're lucky enough to have a 55-inch TV at home, then that's all good. But it does limit your ability to show a lot of information on the screen at one time. We move through to the limitations. Some I've gone into already. It requires exaggerated movement. So when you're further away from the screen, you've got to wave your arms around and make it understand. And if anyone's watched someone try to navigate the menu on a Connect, you see a lot of hands going out like this. You see people moving their arms around and waving their hands and things. And unfortunately, one of the hardest things is to move sideways, to swipe sideways, because when we do it on a touch machine, we have a plane that we hit to move, and we move the other way, and we're in that plane. When you don't have that plane, your hand is moving this way, but the first thing you do when you finish that movement is you move it back like that to where it was beforehand. So those sorts of interactions, it's almost a movement like this that you need to create, because the person has to come away from that plane that they're on when they do it. So there's all this exaggeration of movement. Again, a reasonably heavy software layer. Occlusion is also something that we've come into when you've got more than one user interacting with the machine at once. They either have to stand side by side, which is fine for a game. They can smack each other in the head with their arms, and I suppose that's okay. But when you're just moving around the room, when you're trying to interact with an application that isn't a game, then we get into issues where one person's occluded from the other due to their movement in front of the camera. This causes issues with, because we're only tracking skeletons and basic face shapes. You have a problem with turning and moving sideways of the camera. All of a sudden you've lost their face. You've lost most of their skeleton because they're side onto them to you. And then when they come back around again, unless one of them's standing like this and the other one moves behind them, which is a bit contrived as well, you have the problem where usually the person will turn to talk to the other person as they move around or something like that, and you'll lose all the skeletal structure. When you come and create it again, you've probably got the wrong person and the wrong skeleton, which can cause a couple of problems when you're trying to interact with the user. The other thing is that we have the problem of user fatigue as well. I remember my daughter playing Connect Adventure, and she was playing it for something like an hour non-stop, and having a great time. She came off, she was drenched in sweat, she had to go away to shower, and she lay down for the rest of the evening, I think, because she was absolutely wiped out from it after an hour's play. So that's fine again in a game where you're trying to get your kids up and doing something and exercising and things like that. They don't realise they're exercising. It's wonderful. But when you're talking about, again, an application that is just to be there in the background, is to be doing things silently and well, you find you're going to have trouble if you have your users panting around and laying down for an hour afterwards after they've used your software. So we move on to another input mechanism, which is sensors and sensor fusion. A lot of phones, the smartphones, etc., are all in this space already. They've got accelerometers, magnetometers, gyroscopes, photosensitive equipment, sensors, that really do help you as you walk through life with your smartphone. You find out things like augmented reality systems can take the camera and show you where you are in the world, and show you that the Sky City's over here, and as it did yesterday, navigate me to my hotel quite well. It can also, sensors can also infer the environment, environmental factors, and the environment affects the user. It affects all of us, hot, cold, etc., lighting, ambient pressures, temperatures, all that sort of stuff. Those sensors are just starting to be added to laptops and to systems that we can get in touch with through Windows and through the desktop. They've been in phones for ages, and the phones are really leading the way in that respect. The smartphones are leading the way in this way. They do it well. We're just starting that place. Go on to touch, which is sort of something that I know a reasonable amount about. It's now cheap and ubiquitous. Windows 8 is making it that way. There's iPads and all of the smartphones use touch as well. There are good development tools available. It's a natural interface. We're all used to pushing the button on a microwave or programming our TV or DVD player and recording and doing things like that. So it's very natural. It's a useful thing. We started getting into touch about 6 years ago when a small company in Auckland called Next Window came to us with a proposal. They said to us they had this wonderful hardware system that was going to bring down the price of touch, because at that point you were looking at some of the very smallest or the very cheapest touch systems were $20, $30K. They were looking at $200 or $300 for it. They were the first optical touch systems, and they had the hardware, they had the drivers when we were just starting in Vista, because we didn't have lovely things like Windows 7 drivers and things like that at that point. They weren't standardized, and they came to us because they needed some applications, something to run on, because they didn't have anything, and they didn't have the time to make them, of course. So we, with them, we created some demos and some things to take to the OEMs, because that's where they were pitching them, because of course they wanted them integrated into their systems, and got a little bit of traction through Dell and HP. Their optical touch systems came out on the TouchSmart, and Dell also picked them up, and we were picked up to do the touch suite for them, which started our journey in touch, and it was fraught with a few problems. I think the first release we put out actually went out. Our QA systems weren't as good as they are now, of course. It went out without actually being able to touch the screen and actually use it, due to one line of code not being there. So that was a bit of egg on the face, and I had a fun conversation, because I was project managing at that point. I had a fun conversation with their development representative in Texas about how we messed that one up. So luckily we got through that one, and moved in, and they actually got us to create a slightly more modular system with a sort of separate media player and things like that in it for their later push for both touch and non-touch machines. And that's what's available around the world at the moment on Dell machines. It is crapware. Sorry about that, but yeah, it's the stuff that comes pre-installed on the machine, the launcher and stuff from the Dell machines.
So we've done a lot of work in this field. I've got another, if I can ever get the bloody thing to work. This is one of the early demos that we created for Next Window. It shows a 3D model and touch. This is one of the early screens that was doing only rudimentary 2-touch and using the finger to mould a piece of clay, if you like, and a very sort of nasty texture that was put on top of it. Well, it's a full 3D model, so it's got lighting and all the other bits and pieces, and in a second he'll show that it's actually bump mapped as well, so you can see the point light moving across the surface. So that was one of the things that we started off with, and oh yeah, that's another quick example of some of the gesture stuff that we've been doing as well. So we go from there to its many limitations, actually, all of which we've come across and using in our wonderful journey on the way down using touch. Fat fingers. Our fingers are somewhat bigger than a cursor and a pointer, and unfortunately we have to deal with that because you can't. It's very hard, and you'll notice it on the iPads and stuff to pinpoint accurately, or get to a piece of text in a sentence and things like that. It's just you have to zoom in and things like that. Ghost touching, much more prevalent on optical systems because you have 2 cameras and you can occlude that camera just as you can with a depth camera. But still, we got a Samsung tablet from Build in September last year that is a capacitive touch system like the iPad and most other phones. That whenever you touched it on the left-hand side in a certain place, it ran a string of touches down the right-hand side, which was great for testing, not so great for a user. And it's just the way that the capacitive touch was put together. Touch has been around since 1980, or the early 80s. 83, HP brought out the first touch monitor. It was called the Magic, and it used infrared beams, very similar to the capacitive idea now, but the capacitive idea is inlaid in the machine into the membrane. That you broke a beam, a cross beam on the screen. They were using, it was back in the early days of DOS, of course, in 1983. The user interfaces were quite rudimentary, and of course, because of what they were doing, they were trying to mimic the cursor, they did have a mouse at that point, mimic the cursor and the mouse with the touch, and it failed miserably, and for however many years afterwards, nobody would touch it. And one of the phrases that was coined then was gorilla arm, because people would come away from using this machine because it was touch enabled. They went nuts and made everything touch. You couldn't really use the keyboard for much other than typing in your document that you're using, and so you had to touch on everything. The mouse sort of went away. And of course, users after a day's worth of work, after 8 hours worth of work, they were sitting there and they just, their arms felt like lead, and that's where that sort of came from. And the other problem with touch, especially on these screens, is the fact that there's a lack of haptic feedback. There's nothing to say that I've touched this thing. There's no click click that you get from a keyboard or a button of sorts. So that's another one of the limitations that touch brings. For your average user who sits there banging away on the screen, I've seen people do it even on my smartphone. Sitting there, my partner sits there and goes, "What the hell isn't this working?" And she has actually pushed the button. It's just taking a while for the website to refresh, but she doesn't understand it.
My partner's a vet, not a tech, so, so she's not technically inclined. So, of course, and that brings us through to, of course, the good old direct input mechanisms. Now, these are always going to be around, I think. Well, they're going to be around for a long time till we can sort of get ourselves, get something into our brains a little bit more directly. They're great for content creation. You can do a lot with a mouse, a keyboard, a stylus, and other direct input mechanisms. And it also allows for economy of movement, which is really required when you're at it 8 hours a day. You can't be waving your hands around and playing around with the machine when you're doing it 8 hours a day. Limitations, we all know these. It's nothing new. Being close, like you've got to be at the machine, at the desk. Repetitive strain injuries because you're doing the same thing over and over again with very small micro movements. The thing that we probably as technologists don't know or don't understand because we did it so long ago is the learning that's required. There's a huge amount of learning that's required to. I don't know about you, but I learned to touch type as an adult. That was hard, really hard. I had to think about what I was doing all over again at a keyboard. Before that, I'd learned sort of partial touch typing through chatting and stuff when people were yelling at me for being too slow to respond. But yeah, that was really hard to do. So, and that comes back to your average user, mum and dad. They don't know how to touch type. They can't get this thing to work quickly for them, and it's not natural. It's an abstraction of the movements that we're trying to do in that respect. So, to help us to input all this data and to change it around and move it and everything, we've got some tools that we can use. The .NET framework, and others. This is just a selection, and the Windows runtime that we've now got with the Metro interface. It's made touch and some of these other things a little bit more easy to use, especially touch because it's part of the framework now. You get a tap event, you don't get a click event anymore, and that's all. Although you can separate them out if you want to, it's all part of the system now, and you don't really have to think about programming specifically for touch, because the other thing that you're going to get, and we got when we first started down this track, is that when you go to the Windows Store and you hand it over to Microsoft and you say, "Here, look at this lovely thing we've created," they come back to you and they say, "This isn't right, and this has to be designed differently, and you need to change this because you haven't developed it for touch." So make sure when you are developing these sorts of things, if you are going to be certified, that your applications have big enough buttons that you follow the design guidelines that Microsoft have put out. They're good guidelines anyway. They're good for your application. Because our fingers, as I said, are so much bigger than the cursors and stuff, so you have to deal with that side of things as well. The Microsoft Connect and Speech SDKs will help you further yourself away from the computer. They're all available online. You'll be able to Google them. It's not too hard to find information about them. The Connect SDK, there's a whole lot of examples around about using that, and one of the things you could go away and from this and think about is how you could use something a little bit further away from the computer to enhance your application. Content is probably the most important thing of the whole lot, and I've spent one slide on it because I can't tell you what to put in as your content. I do know that you have to engage the user across whatever mechanism you're trying to use. Minimize the training required, and some of the input mechanisms should help you do that. And the big thing is you've got to give a user a call to action. If they're further away from the computer, it's just a little tiny shiny thing in the corner of the room. It's not sitting there saying, "Look at me." You're not right at it. You're not engaged in using it. You have to ask them to use it. You have to get them involved in it and let them know that they can use it when they come in. As far as feedback's concerned, which is the last of the things you require in this continuum of interaction, we have the 5 sensors that we're using. Mostly we use visual feedback through our screens and things like that. Of course, again, it's sitting in the corner of the room. It's not this big thing on the wall. Well, maybe it is, but you know, your computer's sitting in the corner. It's not something that's barking out and saying, "Look at me," quite so much as it would be. There's audible cues that we can give, and of course now we're just starting to get into the tactile nature. There's research being done at the moment on displays that have a membrane over top of them that push air up underneath underneath that membrane to give a rise or a bump to the surface of the screen, which allows that person to have some feedback on where they're touching. The other two of the five senses I can't see being used too much unless someone's trying to create the best fart app in the world. But you know, that's up to others to use. So putting all this together into an application. This is just an example application that we've created. It is one of the applications that we have out on the market. It's currently only with OEMs. It's an organizer program for application for family use, and this is just one of the usage scenarios for it. It's a little contrived because it is what it is, but it does show someone using it from further away. As they move in, they get more information and can gesture. Still consuming content rather than creating it. Moving across, I wouldn't advise putting your computer quite as close to the hob as that. Probably limited space in the environment, and to show that it was in a kitchen. So this allowed, you know, she's able to draw a triangle, but use the information, change and create different things. Using the webcam to leave a message for the family, or to in this case, make a photo. James's, as you saw, there was just a calendar up there when he was a long way away. Now there's a little bit more information. He moves in further, it gives him a little bit more. Once he starts to want to create content or manipulate anything, any of the data, he has to be at the screen at this point in time. Hopefully that will change in the future, but at this moment, he's, you know, and that's just showing again that he can zoom in and he can use the content without having to be right at the machine, even with his son on ARM. So that's, you know, that's something, bringing all of those things together to show an actual application running. So the conclusions are around this. The interaction continuum, as you can see there, gives a cohesive experience. We're trying to make sure that the user isn't broken out of one mechanism and into another as they move closer to the computer. They can just naturally move in. The information changes. They get some feedback on what they're trying to do. It's all about input and feedback. The user's the most important part. They're the one who has to do it. It's natural as we can make it, at least for the moment. And of course there are a few limitations to the current technology for us to overcome. And the field at the moment is wide open for people to do good things with. It's hard, and because it's hard, there's not that many people doing it. So there's a lot of information. There's disjoint information around about all these things, and some sensors are in some things and not in others, etc., etc. So the future, well, we could have blanket coverage throughout our house or room or office or whatever that knows when we walk in the room, knows that knows where we are and what we're doing. Could imply what our mood is from what we say and where we do things and what we do. Of course, there security and privacy concerns with that sort of stuff. But also, there's the ability to help aged people and people with health concerns. I know that we probably don't have to worry about this quite so much, but falling over in a room where there's no one else around and they haven't got their little ticker thing on them or whatever, alarm on them, these sorts of things could pick that up as well. There's a lot of things to do, a lot of things you can do. These are just some ideas, and there's plenty of other stuff. Most of it is going to come in small bites. It's not going to be this big overarching room of the future idea like those 1950s movies where everything was going to be automated for you. It's going to come in little devices, little things that we do, little bits that we bite off, because it is too hard to do the whole thing at once. And so each step down the road, each step through this process will help along the way. So hopefully you've got something out of this at least. You've been able to think of a few ideas to take away. Thanks for sitting through it. And I can be contacted on this email address, mark.manderson@fingertaps.com. I'll be around for a little while later, but I have to wing back to work after this. Of course, I assume you've probably seen these all before and the other things, but make sure you go into the website and evaluate the session. Being a chance for a prize would be a good idea. Thank you for coming and sitting through, and have a great TechEd. Thank you.